You ever look at a massive skyscraper or a sprawling bridge and just wonder, how does all that steel actually hold together? Well, it's not magic, and it's not just guesswork. It's a language, a secret language, really, made of tiny little symbols on blueprints.
Think about it. On every one of these huge projects, you've got thousands of tons of steel, and the safety of the entire thing comes down to thousands of individual connections.
Well, that secret is the weld symbol. It's this incredibly dense, standardized way of telling a welder everything they need to know, what kind of weld, how big, where it goes, all packed into one tiny little graphic.
Now, let's be honest. At first glance, as our source material for this explainer perfectly puts it, these things can look like a bowl of alphabet soup, just a total jumble of lines and numbers and letters. But I promise you, there's a logic to it, there's a grammar.
All right, so let's jump in and actually decode this language. Because getting a handle on these symbols isn't just for kicks. It's absolutely critical for safety, for efficiency, and for making sure the thing the engineer designed is the thing that actually gets built.
And this isn't just some textbook theory. Take a look at this. These are real-world specs from manufacturer calling out the exact fillet weld sizes required. This is where the language hits the steel, literally.
So, like with any language, you've got to start with the basic grammar. And for weld symbols, that grammar is all built around a really simple framework that tells you two fundamental things: what to do and where to do it.
Everything, and I mean everything, starts with this: the reference line. Just think of it like the backbone of the whole symbol. All the other crucial information, the weld type, the size, you name it, it all hangs off this one central line.
Okay, now this right here is probably the most important rule of all. It's the arrow side versus the other side. If the instructions for the welds are below that reference line, you make the weld on the side of the joint the arrow is pointing to. Simple enough. But if the info is above the line, you weld the opposite side of the joint. Getting this right is everything.
So, we've got the grammar down, now it's time to build up our vocabulary. Now, there are a ton of different weld types, but our source material zeroes in on 4 that you are going to see constantly in structural steel work.
Let's run through them. First up is CJP, or complete joint penetration. This one's pretty straightforward. The engineer basically says, I need this joint welded completely through, and then the contractor gets to figure out the best way to make that happen. Next, we have PJP, or partial joint penetration. Here, the engineer gets more specific. They're not just saying fill it up, they're defining a specific strength required for the weld, known as the effective throat. Then there's the classic fillet weld. You know this one. It's that triangular-shaped weld you see where two pieces of steel meet at an angle. It's defined by its size and its length. And finally, you've got the flare bell weld. This is a neat one, often used for hollow or round parts, where the curve of the steel itself actually forms the groove that you fill with the weld.
And that CJP weld really highlights a brilliant principle here: the division of responsibility. The engineer's job is to define the outcome, a fully welded joint, but they give the fabricator the freedom to choose the most efficient method to get there. It's all about trust and expertise.
Okay, so knowing the language is one thing, but communication can break down, and when it does on a blueprint, it can lead to massive delays and cost a ton of money. So let's look at a couple of common pitfalls the source material points out.
You've seen this on drawings all the time, right? TYP. It means typical, and it's supposed to be a shortcut. But typical of what exactly? If that's not crystal clear, you can get some pretty creative interpretations back in the shop.
The solution is just so simple. Be specific. Don't just write TYP and hope for the best. Write TYP both ends, or TYP all web stiffeners. A couple of extra words on the drawing can save a whole lot of questions and potential rework down the line.
The source material just nails it with this quote: a few extra words can save many extra dollars. I mean, that's the whole ballgame right there. Clarity isn't a nice to have, it's how you save money in this business.
Oh, here's another classic mix-up. An engineer might put E70XX on a drawing. Now, they're probably just trying to say they want a filler metal with a standard 70 KSI strength. But that E70XX format is actually specific to one kind of welding, stick welding. So they've accidentally told the contractor they can't use other, possibly faster methods. The right way to do it? Just specify the strength you need and let the contractor pick the right tool for the job. And all of this, all these rules and potential pitfalls, it all brings us to the final and honestly the most important piece of advice from this entire breakdown. Look, you could memorize every standard, learn every single modifier, and draw a weld symbol that is 100% technically perfect.
But what good is that perfect symbol if the person who actually has to build the thing looks at it and just scratches their head, right? If they have to guess, the whole system has failed.
And that's why the ultimate takeaway, the golden rule here is this. When in doubt, make a sketch. Seriously, a simple, clear drawing of what you actually want is always better than a complicated symbol that someone might get wrong. At the end of the day, clarity is king.
Kind of makes you think, doesn't it? These weld symbols are this whole critical language hiding right there in plain sight. It makes you wonder, what other essential, complex languages are out there, quietly shaping the world around us, just waiting for us to notice?